Well, now on to Chapter 5. Section 5.1 is about proving trig identities. So what you're going to do is be using the trig identities that you already know, like these on the 3x5 card. I left mine at school, so I had to rewrite mine. But that's okay, it was extra practice. So anyway, here's my 3x5 card. So we'll be using these trig identities along with some algebra skills. And what you do is take an identity like, so this is a whole new identity, not one that we've seen before. 1 minus sine of x. And that equals cosine squared x divided by 1 plus sine x. And what we need to do is start with one side of the equation. You usually start with the side that looks more complicated. And basically you use trig identities in algebra to change this until it looks just like that. So let's get started. Like I say, it's best to start with the side that's got more stuff in it and then reduce that down. So we'll start with the left side. So that's going to be cosine squared of x divided by 1 plus sine of x. And then it's usually a combination of one step you use a trig identity, then algebra, trig identity, algebra. So it's a combination of those. So I'm going to use this one right here. Sine squared plus cosine squared equals 1. But if I subtract sine squared from both sides, another identity for cosine squared is 1 minus sine squared. And then it's still divided by 1 plus sine. Okay, next up is algebra. So this is the difference of two squares. Much like in algebra, if you have a squared minus b squared, then you can factor that as a minus b times a plus b. So we'll do that here. So it's going to be 1 minus sine of x times 1 plus sine of x. And then just recopy the bottom part. And then the 1 plus sine x on the bottom and the 1 plus sine x on the top cancel. So all that's left is 1 minus sine of x. And if you look at the given problem, that's what they were saying you're supposed to get. So right here, we're done. So there's the first trig identity. Then for the second one, my fancy production quality pre-written notes. Look at that. Okay, so start with the side that's got more stuff in it. This has fourths, and this is the difference of fourths. Well, just like I factored the last one as the difference of squares, I'm going to start with this side and I'm going to factor it. So start with the cosecant to the fourth of x minus cotangent fourth of x. And then that will be factored basically as the difference of squares, but it's going to be cosecant squared x minus cotangent squared x. And then do the same thing with a plus in between. Now, there's probably a trig identity for one of these. So there's a cotangent squared, there's a cosecant squared. And actually, if you look at this bottom identity, and you were to subtract the cotangent squared and put it on that side, it would say cosecant squared minus cotangent squared is equal to 1. So this one is equal to just a 1. All right, now what about this over here? Well, notice where we're going. Where we're going is it's supposed to have sines and cosines. So I'm going to change this to have sines and cosines. So for cosecant, that's going to be 1 over sine. And because this one is squared, it's going to be 1 over sine squared. And then for this one, I could use this identity, cotangent. So that means this one's going to be squared, so it's going to be cosine squared over sine squared. And then, of course, 1 times it doesn't change it, it's the same thing. And then these two have a common denominator, so you could go ahead and add them and keep the common denominator sine squared. And then it would be 1 plus cosine squared. And then if you look at what we were supposed to get and what we've got, they are the same. So, official check off, yes, number 2 is done. And then for number 3, so with this one, the two sides look basically the same. It's trig function plus 1, trig function minus 1. But I think I'm going to start with this side because cosecant is equal to 1 over sine. So I could use that identity. So I'm going to start with the left side. So cosecant of x minus 1 over cosecant of x plus 1. And then each cosecant gets replaced with 1 divided by sine of x. And now what? Well, now we have a complex fraction. So these denominators are making a complex fraction. So what I need to do is clear that out. So multiply by the denominator sine of x. And then go ahead and distribute. So when you distribute to here, the sign on top and sign on bottom will cancel. It'll just leave a 1. And then distribute here. So that's going to turn it into minus sine of x. And then distribute here. It leaves a 1. And finally distribute to here. And it leaves plus a sine of x. And that is exactly what we're supposed to get. So, cha-ching! Free money. So the ones here in section 5.1 are meant to be fairly straightforward, to be done in like 3 or 4 steps. We will do more challenging ones in section 5.2 and 5.3. So which side do you think looks more complicated? So this is where there should be a little pop-up on the screen where you say the left side, the right side, you get to vote. Anyway, since you're not voting, I'll just go ahead and say, I think this one is. Because this one is saying you need to take tangent plus cotangent. Might as well start doing it. Tangent plus cotangent. And squared means you multiply it with another tangent plus cotangent. So this has more stuff. You multiply it out. Hopefully it'll then reduce to be this over here. So go ahead and start multiplying it out. So there's going to be tangent times tangent is tangent squared. There's going to be tangent times cotangent. So plus tangent of x times cotangent of x. And then distribute, so that's going to be another tangent times cotangent. And then finally multiply these two, and that's going to be plus cotangent squared. Okay, now, well, tangent, referring to my little 3x5 card right here, tangent is equal to 1 over cotangent. So if you replace that here, it'll actually cancel this out. And we could do that also over here. So let's do that. So tangent squared. And when doing these, in each step, you should only be doing one thing. Like here, I'm doing the algebra. Next, I'm doing one thing. I'll replace tangent with 1 over cotangent. Aquí también. And the rest of it will stay. So this is going to be tangent squared x plus 1, and then plus 1 plus cotangent squared. And you might be thinking right now, oh, Perkins has been on vacation a little too long because he should have just done 1 plus 1 equals 2. But I am looking forward to, or thinking about, these identities. They don't have a plus 2, they have a plus 1. So that's why I left it like that. So tangent squared plus 1, that's this one. 1 plus tangent squared equals secant squared. And I'm supposed to have secant squared, so that's good news. And then 1 plus cotangent squared, that's this one down here, so that's equal to cosecant squared. So the tangent squared plus 1 gets changed to secant squared. Oh, that was a sloppy x. Sorry about that. And then this one, 1 plus cotangent squared, is cosecant squared. And that is what we were supposed to get. So this one gets the official check mark. Done. All right, on to the last one. Number 5. So all the ones we've done so far have been true, and we prove them true. But what about this? So it is true that sine squared plus cosine squared is equal to 1. What if you take the squares off? Is it true or false? Well, I have a feeling it's false, and here's the reason I think it's false. Sine squared plus cosine squared is equal to 1. And then I think what somebody did is they went like this. So just take the square root of both sides, and on the right side, the square root of 1 is 1. And if you square root a square, it gets rid of the square and the square root. The only problem with that theory right there is it does not work if there's a plus or a minus in between. So as soon as there's a plus or a minus and you try to distribute, oops, I forgot to get rid of the square. You try to distribute a square root, that I don't think it's true. Now, if you're going to prove that something's false, all you need is one number to prove that it's false. So I'm just going to randomly pick a number. Sine of, what's your favorite number? All right, 12. Plus cosine of 12. Does that equal 1? And now it's a question. So use a calculator. This is in radians because it doesn't have a little circle on it. So this needs to be in radians, which it is. As you can see, I was doing some pretty high-powered math earlier. So this one is sine of 12 plus cosine of 12. Does that equal 1? Nope, not even close. So when you're proving something false, you only need one number to prove that it's false. So this one is false. And that's section 5.1. Talk to you soon.